Okay, so now hopefully you've gotten good at writing K expressions. So you're going to be able to write the equation for a K expression from a chemical reaction. And on the left side it's K equals, and on the right side it would be the concentration of the products raised to their coefficient power divided by the concentration of the reactants raised to their coefficient power. So I get a new expression for every chemical reaction. Now if I could actually go about, some scientists are going to go about measuring all those concentrations and plugging it into that expression, they would end up with a number that would be the K value. So I could actually get a number for that K, the K constant, we would call it equilibrium constant. And if I had that, I could really say something about the reaction. If I find a K value that a scientist has measured, and it's a very large number, greater than 1, like something like 10 to the positive 9, sorry. So a very large number. That suggests that the top is very big in this fraction and the bottom is very small. If I want to get a very big number, I need it to be a big number on the numerator and a small number on the denominator. And since in the numerator is products and in the denominator is reactants, that's telling me that there's a lot of, in this case, H plus and ClO3 minus, or it's very little HClO3 for that ratio to begin. So I have a big top, small bottom. We would say that this is forward reaction favored, or that it favors products, because most of what I have on hand is on the top, which is the products. So if I have a very large K value, it means that when it reaches equilibrium, I have mostly products and very little unreacted reactants left. If the K value, on the other hand, was very small, so much lower than 1, like 10 to the negative 8, so it's a very small number. A very small number means like 1 over 1,000, or 1 over 10,000, or 1 over 1,000,000. So it means that I have a reaction, a fraction where I have a small amount on the top and a big amount on the bottom. If I did that, that would suggest that I have very little H plus and ClO3 minus, or that I have a whole lot of HCl3 unreacted. Remember, on the top are my products and on the bottom are my reactants. So it means I have very little products, lots of reactants. This would say the reverse reaction is favored, or that the reaction favors reactants. And it would tell me that I have a lot of reactants on hand, unreacted, and very little products. So it's almost, on appearance, once it's reached equilibrium, it looks like the chemical reaction barely took place. Only a few things reacted before it reached equilibrium. I could also, if I knew the reaction, the K constant for a forward reaction, I could use it to calculate the K constant for the reverse reaction, because they're just flipping numerator and denominator, so I could take the inverse. You won't really have to do that. But I do need you to understand the size of that K constant, which has to be experimentally measured and given to you, or you'd have to be given the equilibrium concentration so that you could calculate it. But that size tells me something about whether the reaction is product favored or reactant favored.